So it's got these levers for releasing it, right, which is standard sort of thing. So that one's releasing, but this one's all smashed. So I'm going to see if I can get that to turn, and then I might be actually release it off the front panel, and then we can look at what we can do to fix the box. I might just go to there actually, because I can get to that bit. Can I get to that? It's turning. Okay, it's turned a little bit. That one's fully off. This one's not fully off yet. Also, I'm trying to avoid damaging it any further. Let's get in there. It's very tight though. It's all probably wedged because of the damage that's happened to it. Okay, that lines up now. So hopefully I can wiggle it off. There we go. As you can see, it's all bent in. Hopefully the front panel side's okay. That one is bent. Yeah, that one's bent downwards. So I might have to do some minor repair to the front panel as well to straighten this up, which doesn't surprise me. I'm not too worried about that, as long as they're actually intact, which they are. I could actually check that. I do actually have another fitment here I could put on. So I've got one of these test fixtures, which if it's straight will go on. Well, it's nearly going. Yeah, they will actually go on. Look, that locks on. So it's actually straight enough to be okay. Even though I can see it's very slightly wonky. You can see that's also slightly skewed. So this end is slightly more that way. But it does still go on. So it's only a really minor bend. It may not even be worth fixing it. Let's pull this apart. Let's open this up. See what joys we have inside. See, what's possibly is wrong with this is that it could be that thing failed, it stopped working, and then they got annoyed with it, chucked it out, disposed of it in a bin or something, you know, which is why it's all got smashed. It's landed on its front. It may not even be anything to do with this. It could just be this was just a casualty of it. But I can't see any damage in there apart from the fact it's all bent. There's nothing like shorting out or anything like that, or any ripped cables. I'll have to see what I can do about straightening this up. I really want to take these connectors off to do that. I'm not sure I can actually strip these down because they've wired in already. I can certainly take that one off. It's the only one I think I can take off. There you go, a closer look at it, in case you wonder what's inside one of these things. It's basically a bunch of cables. So this one is the negative. Not got anything on it, which is interesting. I thought that it'd actually have something on there. Surely it must do something. Maybe this test fixture doesn't do anything. Strange. But the other ones have all got these connectors going to them. I would like to get this out and have a closer look at it. Right, okay, so one of the wires is going straight to the casing as a grounding. Okay, so that's probably what that one would normally be doing. Yeah, that'd be the low current side. So that's probably just the casing. So I'll just loosen this nut off a little bit. So we've got a metal washer, plastic washer. This is kind of wedged in, there we go. And there's a fitting which is also, it looks like it used to be a spacer which is split. There's the mounting spacer. Okay, I have to look at what I can do to sort that out. I might be able to 3D print some pieces for this. Give you an idea of exactly how twisted it is. I don't know if I can disconnect these to get these off. There might just be like connectors. Could they be that convenient? I doubt it, but let's have a look. The whole thing's twisting. No, the whole thing's going with it. I might be able to actually, if I do that, then undo the nut. Maybe I can spin the whole assembly out. I think if I could turn that I could unscrew that from the wiring rather than being the other way around. Yeah, I think I do need to try and get these out if I can, so I can straighten it up. So I've straightened up kind of, it's kind of there. It's not perfect. I've taken off the last fitting. That last fitting's only used for alignment anyway. There's no electrical connections to it, even to the casing. So I've just left that off because it's actually getting the negative current, or the low current I should say, from the casing, which is done at this end of that terminal there. because that's under the chassis. So it's actually like a washer on that one. So that's actually one which is important. This one doesn't actually do anything, just there for alignment and locking it on. So because I don't actually have this thing perfectly straight and everything, it's, you can see it's still a bit wonky there. I'm just sort of trying to get it in there to make it work and just test it out. I've also got this other fitting here. You can also plug this one in and try that one out. But for now I thought I'll just try it like this and confirm this fixture is actually working. So I've got Kelvin clip onto the negative post on resistance box, not at all precise. And I've got the probe here which has got like a pogo pin on it. I'm shoving it in there to make contact. Alright, so I'm going to push it down, try and get a decent connection on it, and hopefully you can see on the screen over here what it's actually doing. So I'm going to try and jig this up so you can see, but I also want to show the setup first. Alright, let's push the probe down so I've got a decent connection, hopefully. Well, as good as I can get on this. So it's currently set at 0 ohms, so we're getting 81 milliohms there. Let's keep fiddling around so we don't get anything different. 81 milliohms, move the box around, yeah, that's okay. So let's do 1 ohm, there we go, that's there. 2, so it's actually reading those. 3, I'll try and go up to 10, or 9 is maximum I've got on that one. Yeah, it's jumping around a bit. Let's go 40 ohms, there you go, 40 ohms, 90, yep. 100 ohms, 500 ohms, 900 ohms, yep. Now I've got no idea how to actually use this piece of gear yet. It's got all sorts of settings on it. I don't know, I've probably got it set up wrong. I've got it in auto mode, I think. So here's what it is: 1K or thereabouts, 2, yep, 5K, yep, and 9, yep. Accuracy, I don't know yet. We'll have to look at that. So 10K, 50. Starting to look a bit weird there. 50 is not looking right. 90. Also not looking right, so there's probably some kind of setup issue here. 100, can't read that. 500, can't read that. 900, can't read that. So yeah, if I short those together on the same post, there you go, getting minus 34 ohms actually. So I think part of this problem is I need to figure out how to use this, how to set this up, because right now I don't have a clue. I've done auto level. My headset is auto level. I'll just poke that button, so now it's doing that. So auto level. Measuring parameter, it's on resistance. As far as this other stuff goes, I've got no idea how to set it up yet. Should probably go and read the manual, but it is at least doing something. So let's try the other test fixture instead of using this one, because this one's a bit glitchy. Let's try plugging in this brand new one here, and we'll see how this comes out. So there's the fixture installed. Let's just shove a short in, and we're getting 5 milliohms. That's looking promising. Let's get something to test it with. So I've stuck a couple of wire leads into these terminals here with some long leads going to my resistance box. So I've got it set to 0 ohms right now. 1 ohm, yep. So obviously got a lot more extra resistance there, but it is working. Let's try doing 100. It's there, but it's jumping around a lot. I'm not quite sure how to set this up for this particular function. High limit 0 ohms, really? Yeah, I don't know how to set this up yet. But anyway, it's kind of there, but it's not quite reading the kilo ohms ranges right. I'm not quite sure what the specs are on this for what it's supposed to go up to. It obviously is a milliohm meter, but I thought it'd do ohms as well, you know, maybe up to meg, I'm not quite sure, but it kind of wants to go up that high, but doesn't quite do it. It's probably my setup. So I thought I'd go into configuration, line frequency set at currently 60 Hz, well I want 50 Hz, that might help for a start. Got a test function, I suppose we could run that, couldn't we? Run self-test. Let's disconnect these, and we'll do a self-test. I guess that's what it is. See what happens. Self-test passed. Okay, well it looks like it's actually working in it. Great. Exit that. Alright, well now I've changed that line frequency. See if that's changed anything with this. See if we get a better reading now. 100k, still jumping everywhere. Right, so I've got my Fluke current shunt here, which is basically a resistor box. Low value resistor box, so it's basically a divider, and it will give an output here. So we can actually use this to substitute resistors of quite low values. So let's shove this probe in here. Actually I'll shove it in this one first. We'll check the zeroing. Zeroing is close. Let's just do a new 0 on that. Short. And pushing the button. Right. So that's pretty close to 0. So I'm going to shove it into the other post. So we're getting 70 milliohms on a 10 amp range on that one. Let's do the 1 amp range, we're getting 0.164, and 0.1 we're getting 1k. So it should be 1k, 100 ohms, 10 ohms, should be 1 ohm, 0.1 ohm, which is very long way out, and 0.01 ohm, which is also a very long way out. So I think, I don't know if this is reading wrong or whether it's this box. More precision resistors needed. So here is a 0.01 ohm, which I've measured as this at some point. Let's chuck it on here and we'll see what we get. Getting 11 milliohm. Let's do another 0 on that. Probe in there again. See, 11 milliohm. That's what we're getting on this one, which is interesting. Bit different. So I think I measured that with my 8.5 digit meter. Well, let's try this 100 milliohm instead. Let's see what this one comes out like. 100.85. And I'm getting a reading slightly low on that one. Okay, well it's close at least. I need something better. So I've tried different combinations of this thing and it kind of seems to work. I'm getting some slight errors at the lower ranges, but I don't know which is wrong, whether it's this or whether it's my other measurements, but I think this is probably slightly out. I'm not sure. This fixture's not great. It does seem to be working okay, but it's unhappy, I suppose the word to say. I think I need to get some different probes for this thing. I mean, this one's right. This little thing here is a spring probe, and that's actually working quite nicely. I think it all actually is, but I think I'd actually like to get a pair of clip leads and a pair of these probes. I think I need to get like one of each if I'm going to keep using this particular fixture. Now this does actually only go up to 100k apparently. That's the maximum, it's 100k, even though it was really higher than that. So I pulled this thing apart and I panel beat it, and it's now looking pretty straight. It's not too bad. It's not perfect, but I think it's going to be good enough. It's certainly a lot better than it was when I started. I think it's going to be fine. Now the hard bit of this is getting these things out. And now this little bit of C-plug, so basically you've got some insulators on, alright? So you've got the nylon insulator on the back. You've got this plastic insulator, which as you can see is all split and broken, right? Because they've been pushed and it's basically shearing it off through the hole. So what I think I'm going to have to do is try and 3D print some more of these little plastic spacers. They won't be as strong as the originals, but I think that's what I'm going to need to do to try and restore this thing back to how it should be. Because without these being any good, you could probably glue them, probably could glue them on together, but then it's full like a nylon or something, so I don't know, they probably won't glue. Yeah, I need to make some more of these. But part of the problem with getting this thing apart is that all these little plugs on the end here, these are crimped on. So this thing got the inner conductor, which in this case is broken off. In fact, they're all broken off when I was trying to do them. And this outer nut here is spinning, but it's crimped on. So they've somehow crimped that in place. I'm not quite sure how. Or they've accepted the fact this can be twisted. And then you have to unscrew it off the terminals. Yeah, it's not an easy one to do. So I think I'm going to have to end up stripping back some of this insulation here, so I can slide this back further, so I can resolder that center conductor and then put this back on again. But I've got to do that for all three of them. Obviously I haven't got the grounding one. I've just marked these 1, 2, 3 so I know where they all go. The reason I had to pull that apart is because of these little plastic washers, these spacers. These have to be replaced. So I had no choice but to pull it apart and risk breaking it further. Yeah, well, it's one of these things, isn't it? So the other thing I'm also attempted to try and design is this little lever which goes on the BNC connector. Now, I've been trying to find these. I can't find these anywhere. Someone's obviously injection molding these things to do the job. Obviously HP did at the time. But there's adapters like from China, like this. That basically a copy of the HP one. Look at that, even the profile's the same. It's basically a copy of HP. So I was trying to find these. I can't find these connectors with these levers on, or even just the levers. It'd be nice if I could just find those, that'd be perfect. I'm not even sure I really need to do that. On this particular fixture, this left one is not even used or anything, it's actually just there as a locator. So, even just having just the right one in there and locking on with the right one is probably good enough. I mean, if I can 3D print one of these as well, I haven't drawn it up or anything. I've got no idea the best way of doing that yet. I'm thinking maybe the trick is to actually make one of these and then like melt this into it or something. I don't know. Not quite sure the best way. Obviously you've got to get decent fitment on between the two. I could go slightly bigger and rely on glue. I mean, glue might be okay. It's not a lot of stress on it. I don't know. I need to design something for that as well. Anything I do design to be 3D printed, I will chuck that on my Thingiverse page as well, so you better find it on there to help other people out in this sort of situation. Well, so that's 3D printed the spacers. Hopefully these are the right size. I've got dimensions right. I'm not completely sure the print's gone well. I might need to adjust the settings a little bit, but you got some stringing in here, that's nothing. But let's see how they actually physically fit. There's only like a half an hour print, so I wasn't too worried about wasting too much time on these. Support structure in there, I've got to take this out. That came out easy, that's nice. It's the first time I used PLA Plus. First time I used it, so I've been quite pleasantly surprised by how that's printed. Now what I don't like is the way it's got a join in the wall. Let me show you. This is Cura for you. It's put a join in the wall right around there, which I didn't really want. I didn't really want to join. See that kind of halfway through the wall in there? Little gap just there. Yeah, the idea of these is they need to be quite strong. I don't think that's going to do it. I might have to do this again with, I don't know, something, maybe more of an overlap or something. We'll try it, see if it physically fits, so we'll go with that bit first, and if it physically fit, that's a good start. So let's try it in the casing first. Ah, perfect. It goes in, a little bit of play. Excellent. Okay, let's try it on one of the B and C connectors. Got that stringing in there, got to try and push out of the way. That isn't feeling right. It feels too tight. I may need to increase the inner bore slightly. Yeah, well, let's just try and... Okay, I might have to sacrifice one to try these out. Let me just give us a trim. So I'm not liking the way it's got those little gaps in it. I don't think it's going to be strong enough. There you go, now it pushes it. Yeah. There's that recess on the outside which this should also drop into. Which it's not. Did I get those dimensions wrong? Maybe? Not quite the right dimensions. It's not quite right. So I think I need to make that centre hole, or that hole there, slightly bigger. Put a lot more overlap on it. I'm just worried about these not being strong enough once that's actually in place. It's not too bad though. Alright, let's just try and fix these print settings and get this so it doesn't got these gaps in it. It's obviously a wall setting or something. I've had that problem before. Then I will improve that fitment. So I've printed a lever to go on here. Now it's actually a bit undersized. I'm finding my printer tends to print things like the holes are slightly undersized. This is 0.1mm smaller than it should be. And that probably won't matter though. I'm not quite sure what the interference is of these knurling on here. If I try and get it roughly opposite, it's like 14.4-ish. Yeah, with the knurling on there. 14.3 without the knurling. This is 14.3 inside. It's 14.4 across the knurls. So it might just squeeze on. It's sort of starting a little bit. It might just be able to get in there. So if I can get it in the right place, it has to be halfway around that slot. I might be able to push it on. If it doesn't go, it breaks, and oh well, I'll put another one out. It's not like a big deal. But if I do print another one, I'll have to make it slightly bigger. So I think I might change the model very slightly. Another thing I could do is actually warm it up. I could like heat this up slightly with a heat gun, soften it, and then it'll make it expand slightly. And I could probably do it that way as well. Let's just try pushing it on. See if it will push on. It might. It's starting to go. I'm not in quite the right place though. Turned it slightly. About there. So I think I need something to push this more evenly. Let's try it like this. Oh, it's going. That could actually work. Let's keep going. Oh, it's kind of on there. Compare it to the original one. So in the original one you've got no knurling showing up. And this should do the same. So it's not quite bedded right down. You should have a bigger step on the back there. You should be able to say so you can see that whole flat there. We're not seeing all of that yet. So I might just keep pushing it and see what happens. If it breaks, like I said. I don't really care that much if it breaks. There you go, let's move some more. There we go. That's right down. Beautiful. It worked. It might be in the right place if I'm lucky. Sweet. So that model will be on my Thingiverse. That's like a perfect fit, really. I'm still trying to tweak the size of this. The outside bit there, it fits beautifully, but the inner bit is being, say, printed undersized very slightly. So I'm actually having trouble getting the BNC to fit inside it properly. It's not dropping in, even though I've made it slightly bigger already on this one. It's still not dropping in, so I've had to tweak the model a little bit more. Hopefully, third time lucky. Need to get it right. So I've got the size just about right now. I've been dialing in, and I've got it really close now. So here's one I've just got to prepare. Now, because I do have this over extrusion thing going on the very first layers, and I've got this stuff here going on too. Get rid of that. A bit of stringing. So there's that one there. So there's the one I've already done, which push fitted on. And I've got to do US them as well. This one needs a new one on it as well. All the originals are broken. All of them are. So I'm going to replace the whole lot with the new ones. Well, the second printer's finished, and I'll just do a tiny bit of clean up on this edge, just on these two edges here. Not on the flat sides, and that now drops in quite nicely. You get a slight push, and there you go, it's in. So that's great now. I've got those ones tuned to perfection. Happy with that. So I'm just assembling the fittings back in now. Hopefully it's all straight enough. I think it is. So what I'm doing right now is repairing these cables, where obviously they've all disconnected from the back of these terminals here. So I've actually stripped back some of this insulation on the back here. So I'm going to slide this back further, so I can then get to the center conductor, trim that back, and then solder that and tin it, get it ready. Just got to do the last one here now. This will be the one which goes wrong, which is why I'm going to video it, because it's always the last one. Try not to cut too deeply, so I don't want to nick the wires. If I nick the wires, I'll be starting again. There we go. Alright, that's that one. Just tin this. Takes a bit to get the solder to take on these. Those are very old wires, so. That's that one tinned as well, so they really go back on. Now what I've got to be really careful about here is when I do reattach them, I've got enough turning on here, because I've got to actually turn these nuts and do them up. Now what I'm hoping I've actually done here is actually help that situation, because what I've done is I've made these front spaces very slightly thicker, maybe 0.5 millimeter. And what that does is it means I've got slightly less thread on the back here, which means this has got to screw on by less. So there's going to be less stress on the cables when I'm trying to screw these things on. These are the shields. I mean, this is to shield these connections. I think once I've got that soldered on, I can sort of turn it back a couple of turns, then do it up, and it will be in a neutral state when it's fully done up. I think we'll be pretty good then. I mean, I can see how many threads are on these. See the threads there? So that's how many turns I've got to get out of these, sort of like 2 turns. That's the tricky bit, is doing that without breaking it all. Alright, so I can film this. I don't know if I can or not. Turn some more lights on actually. Okay. Okay. Now I'm going to secure this one before I move on in case I put stress on that wire. So that's what we push down. Then I want to turn it a couple of turns backwards, kind of like that, and then turn it on to screw it down, and hopefully I'll end up with a neutral position. Snip that up. So basically all we're going to do now is repeat the same thing for the other two. So number 2's number 2 there, it goes on the next one over, and number 3 goes on the last one. Simple enough. Don't have to see me do the whole thing, do you? Alright, that's what I was reassembled. Hopefully it actually works. Right, it's all tucked back in there. I've straightened out the brackets on the top cover as well, and straightened the top cover out slightly because it was also slightly bent. Let's see if it all fits together. Okay, it's looking promising. Right, let's put those screws in. Nearly there. let's try it out. Plug this in. Should line up. It does, just about. Get these lined up, so it'll go down. Yeah. Those will both lock in. Brilliant. So far so good. Let's pair it up. And we'll see if this actually measures anything. Well, I've got some stuff here ready to go. Let's hook up to it. So we've got a 10k to start with. We'll clip it on there. Now because this is not a clip lead, I have to push it on. So we'll see what we get with that. 9.96 or so. Jump around a little bit. Let's do the 1k. So 0.999 something. That's what I've got on this one. Let's try 100 milliohms. Well, it's actually like 0.09991 according to my 8.5 digit meter. There you go, 100 milliohms there. And then we've got a 10 milliohm. There you go, 10.096. This is without zeroing. Actually, I should probably zero it, shouldn't I? Shove it on there, zero it. It's actually looking pretty close to zero, to be honest. Look at that. So it's a bit different to what I was getting on my 8.5 digit multimeter. Which one's right? I actually don't have a clue. But I do actually want a better clip lead. I don't like the fact I've got a clip lead on one and a push probe on the other, because I think I'm probably interfering with the setup. As far as other stuff we can do, I don't know, measure parameters, just on resistance only. Settings, I don't actually know what all this stuff does. I really need to go and read the manual. No idea. So this does a lot more than I have explored yet. These things do a huge amount of stuff, and I don't know how to use it yet. But it is at least functioning. It's looking close to what it should be. It may be slightly out of calibration. I don't really know. Values are reading slightly higher, but it's 26 degrees in here, so it's a bit higher than it should be. So maybe that's part of the problem why they're reading slightly high, because the resistance does increase with temperature generally. Very slightly anyway. I think these aren't too bad for that. But the parts I 3D printed for this are available on my Thingiverse. So the little lever here and those little spacer insulators which are on the BNCs, I've put those on my Thingiverse page. So that's linked down below in the description if you need those parts. Not necessarily just for this particular thing, but for other BNCs, because this probably fits any BNC really. If it doesn't, you can probably tweak the design slightly to make it fit. That's what it's for, is this, for these fixtures. So there's a good chance that you get a fixture with one of these broken. I mean, I've seen quite a few of these broken online. Printing a new one of these out is okay. The only problem with this is it's pushed on from the back, which means you have to dismantle the inside. You may or may not want to do that. You could probably take away the lip that I've got on there. Just have a hole goes right through. That way you can push it on from the front. Maybe put the lip on the other side. That might be an option, so you can push it on from the front instead of from the back. But I just copied the original design and kept it the same. Obviously it's not exactly the same, it's very similar, but it's not exactly the same. So when I first got this little pogo pin thing wasn't actually sticking out into the probe, it was just the probe body itself. That pin wasn't sticking out. Now what I found, this is all chewed up, that wasn't from me, that was already there, and it's actually got a split in the end here. I might need to glue that up or something, but this unscrews. Okay, then you slide that back. Then this also unscrews. And there's the wires, and in here is like a spring assembly. Let's push it out. So when I got this, it wasn't actually sticking out at all. So trying to push it down. There's the probe. So when I got this, this was not sticking out. So what I actually did is I just got this spring here and just stretched it very slightly. Put some tension on it. Okay, so that then means it can stick out. Now also in here we've got like a little sleeve. You can't really see it there, but there's a little sleeve just there which is insulating this from this bit, so it does the 4-wire measurement thing. Alright, so that has to be pushed back in, maybe with my dirty tweezers. Then you can wind that back on, and there's a probe sticking at the end there. So if you get one of these and the tip isn't sticking out, dismantle it, and you can just stretch that spring just a little bit. You don't need to put too much on it, just a little bit, just enough to bring it out. But I do want to see if I can fix this probe body. I don't know if I can or not. So it's got a crack in it, so I'm probably just going to glue it, let it dry, then put it back on, because it's only going to get worse. So I did actually open this up and have a look inside it, and it all looks pristine in there, spotless, all intact. All the capacitors visually look perfect. There's no sign of bulging, no signs of leaks. I think it's actually fine. I haven't done anything to actually consider even replacing the caps. I'm not even going to worry about it. It looks absolutely fine inside. So although the outside had a bit of a hard time, it's okay. I'm going to give this thing a clean up now, and I'm not quite sure where I'm going to put it. I don't have any space on my desk here, so I'm going to have to figure that out. But at least now I've actually got something which can do those levels, apart from my 8.5 digit multimeter, which I don't completely trust for this. This is probably more accurate, but I don't know. Other videos you can watch down there, they have a playlist you can watch, other repairs, things like that. Subscribe link over here if you're not subscribed yet. And also over here is a Patreon support link right there, which you can join the channel, and you can donate a couple of dollars a month, and it helps me to buy a test gear like this to do videos about and to fix.